So in today's class we will learn about the law of parallelogram of forces. So this derivation is an important derivation. Usually this derivation is asked repetitively in examinations, either derivation or problems related to this derivation. So before going into this law of parallelogram of forces, I would like to tell few properties of parallelogram so that it would be easy to understand what is this law of parallelogram of forces. So properties of a parallelogram are, first one is opposite sides are parallel. So let me draw a rough sketch of a parallelogram here. So let us take this as a parallelogram A, B, C and D. So opposite sides are parallel and equal. So these two sides are parallel to each other and the value will be equal. For example, if this is of 3 meter, this will be equal to 3 meter and these two will be parallel to each other. And these two sides are parallel to each other and their value will be same. So first property of a parallelogram is opposite sides are parallel and equal. Now second property, we can call it as opposite angles are same or equal. So if this angle opposite to this is these two angles, this angle and this angle will be same, this angle and this angle will be same. Now third property is corresponding angles are congruent to each other. Congruent to each other is nothing but the corresponding angles are same. If I extend this line here, okay, this angle and this angle are same. These two are corresponding angles and they are same. Next, fourth one, if a diagonal is drawn here, if I draw a diagonal here, it divides this parallelogram into two triangles. See, this is becoming a triangle. This one is first triangle and another one is second triangle. These two triangles are congruent to each other. That is, the properties of these two triangles will be same. So if I draw a diagonal to parallelogram, then it forms two triangles which are congruent to each other. As I am showing here, these two triangles are congruent to each other. Apart from this, let us know few of the trigonometric properties, basic trigonometrics. Let me draw a right angled triangle. So this angle is a 90 degree. Let us take it as a theta A, B and C. So if I want to find out sine theta is nothing but opposite divided by hypotenuse. This is the hypotenuse of the triangle. Since angle theta is given here, this side will become opposite and this is the adjacent side. So sine theta is given by opposite divided by adjacent, that is BC divided by CA, and cos theta is nothing but this one. So cos theta is defined by adjacent divided by hypotenuse, where adjacent is CA divided by hypotenuse is AB. Sorry, here also hypotenuse is AB. BC divided by AB and CA divided by AB. And tan theta is given by opposite divided by adjacent will give me the tan theta, that is opposite divided by adjacent. So what is our opposite? Opposite is BC, adjacent is CA or AC. So in this manner we will find out the value of sine theta, cos theta and tan theta. Apart from that, few basic trigonometric values are sine square theta plus cos square theta is equal to 1. Sine 2a is equal to 2 times of sine a cos a. This we have read while in the mathematics called half angles, usually half angles. So usually it is sine a is equal to 2 times of sine a by 2 into cos a by 2. In this manner we used to know the value. So sine 2a is equal to 2 times of sine a and cos a. One more value we need to remember is 1 plus cos alpha is equal to 2 times of cos square alpha by 2. This we used to derive in our mathematics. So you can directly remember here 1 plus cos alpha is equal to 2 times of cos square alpha by 2. Sin 2a is equal to 2 times of sin a and cos a. Apart from these, we have few more formulas like sin a plus b. So this sin a plus b can be written as sin a plus b is equal to sin a cos b plus cos a sin b. So all the formulas are related to these, that is sin a plus b, cos a plus b can be written as cos a cos b plus cos a cos b minus sin a sin b. If possible, kindly remember formulas of these also, sin a plus b, cos a plus b. Also find out sin a minus b, cos a minus b, and apart from that one more formula is tan a plus b. These are few of the basic formulas we need to remember. Apart from that, let us see what is Pythagoras theorem. In 10th standard we might have read about this Pythagoras theorem. If for a right angle triangle, hypotenuse square, that is AB square, is equal to AC square plus BC square, that is AC square plus BC square. This is our we have this value from our Pythagoras theorem. So these are the basics that are required before going into the law of a parallelogram. So now let us define what is this law of a parallelogram of forces. It states if two forces acting at a point be represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal of a parallelogram passing through that point. So how it is defined? Statement is defined in such that, for example, let us take this as a force P, this as a force Q, and let us assume these are making two adjacent sides of a parallelogram. These two forces, force P and force Q, are two adjacent sides of a parallelogram. Then the diagonal passing through this will be the resultant. This itself is the law of parallelogram. So here, if two forces, that is P and Q, acting at a point, see here, the P and Q both are acting at the same point, be represented in magnitude and direction. So force P is represented in magnitude and direction. Force P and force Q are represented in magnitude and direction by two adjacent sides. These two are the adjacent sides of a parallelogram. Then the resultant is represented by here. This resultant is represented in magnitude and direction by the diagonal. So we are drawing here a diagonal of the parallelogram passing through the point. This diagonal should pass through this point. Then it is called as a resultant. Once again, if the two forces acting at a point, be represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant is represented by magnitude and direction by diagonal of a parallelogram passing through that point. So this is the statement of the law of a parallelogram. So before going into derivation, I would like to classify this derivation or categorize how to derive this one. So first one is a statement, which we have already defined. Next step should be figures related to this derivation. Third step is explanation of drawn figures. In the fourth step, we will be going for derivation of mathematical expressions. So before going into the derivation, first we shall know why this derivation is required and what is the importance of this law of parallelogram of forces. Law of parallelogram of forces is used to determine the resultant of two forces acting at a point in a plane. What is the importance of this parallelogram? This law of parallelogram is to find out this resultant of these two forces acting at a point. If two forces are acting at a point, to find out the resultant of these two forces, we require this law of parallelogram. So you already know what is the statement. So in a derivation, now we are done with the statement part. Now let us go for figures. So these are the figures required to derive the parallelogram equations. That is, in this we will be finding, by using the law of parallelogram, we are finding the magnitude and the direction of this resultant are. If let us consider these two forces P and Q. Now these are the three diagrams which can be clubbed into single diagram. This single diagram is sufficient in examinations, but to explain you, I have separated out these diagrams. So let us take first see here for this one how to give the explanation of these diagrams. Let us consider let two forces P and Q act at point O such that the force P is represented in magnitude and direction by line OA, and force Q is represented in magnitude and direction by OB, where and these two forces, the forces P and Q, are acting at an angle alpha and they are making an angle alpha to each other. The resultant of these two forces will be obtained. The resultant of these two forces will be obtained in magnitude and direction. In magnitude and direction by the diagonal passing through point O. So this is the force P, which is represented by magnitude and direction by OA, force Q represented by magnitude and direction by OB, and force P and Q are acting at an angle alpha to each other, and the magnitude and the direction of the resultant is given by the diagonal passing through the point O. Now see here, this resultant is making an angle theta with the force P. So remember one thing, if these P and Q are interchanged, your final expression there will be changes in your final expressions also. So don't panic in examination if the whatever the derived in class the expression changes in the examination may be due to the interchange of these values, that is P may be written here, Q may be written here. Because of that there may be a change in their final expression, so the expression will be correct. So in my next class I will continue the mathematical expression part of this derivation. So till now what we have done, we are done with the statement, the purpose of this derivation, and this is the figure, and explanation of the figure is covered in this video, this part. In the next part I will be covering how to use this figure and go for the final expressions. Thank you.